Now let us learn about magnification equation, where the formula is h apostrophe over h is equals to negative q over p. To learn how to solve using this equation, let us look at a problem. Example 2. The virtual image formed by a convex mirror has a height of 5.4 centimeters. This image is located on inside of the mirror 1.2 centimeters from the vertex. If the real object was placed 2 centimeters away from the mirror to produce this image, what is the object's height? The given of the problems are h apostrophe, which is 5.4 centimeters, and variable q, which is negative 1.2 centimeters, and variable p with 2 centimeters. What is asked? Uh, h, which is the height of the object. The, the problem asks for the height of the object. And the formula we're going to use is magnification equation. Hmm, because h is on the denominator, we need to reciprocal so that we can transpose h apostrophe to the other side and we isolate h. So we can't transpose h apostrophe if h apostrophe is numerator. And when they reciprocal, the h will go to numerator and h apostrophe to denominator. We can transpose and we isolate variable h. And now the formula is h negative p over q times h apostrophe. Okay, then let us solve by replacing the terms with values. H is equals to negative 2 centimeters over 1.2 centimeters times 5.4 centimeters. We times these two and then we get 10.8 centimeters. And then we divide these two, we get negative 9 centimeters, and there's still the negative sign here, but and our integer is also negative, so negative negative is positive. So our variable h is 9 centimeters. But uh what if we use the two equations, mirror equation and magnification equations, in the same problem? Let us look at the problem. Example 3. An object with a height of 4.5 inches is placed at an unknown distance from a concave mirror whose focal length is 3 inches. What will be the height of the image formed if it appears 4.8 inches in front of the mirror? In this problem, the given are variable h, which is 4.5 inches, variable f, which is 3 inches, and variable q, which is 4.8 inches. What is asked is the h apostrophe. But what is asked is the problem h what is asked on the problem is h apostrophe, and the equation to solve for h apostrophe is magnification equation. But wait, we are missing variable p, so we can't solve for h apostrophe. We're missing this one. So what we're gonna do is look for variable p by using magnification. Wait, is this magnification? By using mirror equation. Yep, mirror equation. Okay, derive the problem to isolate the p. You know it already, yeah. and then transposing fractions and then merging the right size fraction, we get q minus f over f multiplied by q. Then reciprocal to make the p a whole number to get its true value. Then replace variables with terms. Replace variables with terms. Replace variables with terms. So P is equals to 3 inches times 4.8 inches, and 4.8 inches negative 3 minus 3 inches. Wait, let me re-speak that. P is equals to 3 inches times 4.8 inches over 4.8 inches minus 3 inches. And let's solve times 4.4 inches, and then 1 over 1.8 inches, and we divide them, and then we'll get variable p is equals to 8 inches. Now that we have p, let us solve for the what is asked, which is h apostrophe, and we're gonna use the magnification equation and derive it so that we isolate the h apostrophe. Now we don't need to reciprocal because h apostrophe is already numerator, and we can transpose the h to the other side with, and now we have h apostrophe is equal to negative q over p times h. Let us replace the terms with values. H apostrophe is equals to negative 4.8 inches over 8 inches times 4.5 inches, and we times this, and negative 21.6 inches over 8 inches, and we divide them, and we get negative 2.7, oh wait, negative 2 point, oh no no 21.6 over 8 is equals to 2.7 inches, but we still have negative here. We bring it down, we multiply them, and we get our h apostrophe is equals to negative 2.7 inches. And continuation in looking for the location, orientation, size, and type of image, for short L.O.S.T. Let's try to learn them. First is location. So how do we get location? This is from example number 3, by the way. These values is from example number 3. So L, how do we see L? To find L, we draw a ray diagram of the concave mirror, and measure the length from vertex to center. Measure length from vertex to center of curvature by using the focal length value of the problem. Our focal length is 3 inches. Line FV is 3 inches, and line CF is also 3 inches, and overall it's 6 inches. And so the length of vertex to C is 6 inches, and we use our variable Q 4.8 inches to locate what part it is. Well, yeah. So 3, it's not over V and F. 4 is over here. So 4.8 inches is somewhere between C and F. So our location is between C and F. That is our location. And in looking for our orientation, the O, when looking for our orientation, we just look at the value of our H apostrophe. We just look at we just look at the value of our H apostrophe, and if it is negative, then it is inverted, and if it's positive, it is upright. Then here, in this problem, the value of H apostrophe is negative 2.7 inches. So our orientation is inverted because it's negative. So our orientation is inverted. Next one is size. Hmm. To look for the size, we just compare variables h and variables h apostrophe and h. Yeah. And if variable h is bigger, then our size is smaller. But if h apostrophe is bigger, then our size is bigger. In the problem, h is bigger than h apostrophe. And if h is bigger, then our size is smaller. So our size in the S part is smaller. Now for the last, the type of image T. We just need to look at the value Q, and if it's positive, it's a real image, and if it's a negative, then it's a virtual image. In the problem of the value of Q is 4.8 inches, which means it's positive, And then the type of image is real image if it's positive. That is all. Thank you.